Unmute myself. Hey, everybody. So I'm Eric Randall with Baicells Technology, and today I'm joined with Mike Hughes. I'll have him introduce himself in a second. And we're going to discuss about private LTE, what Baicells does, what Winncom does, and how essentially we all make it easy. Go ahead, Mike.
Hey guys, my name's Michael Hughes. I'm a solutions architect at Winncom. I actually over in Seattle, Washington, and I've been in the wireless industry for quite a while, including the data networking industry. But recently, I came from a CBRS service provider to Winncom.
Perfect. Thank you, Mike. So just to let you know, we are covering coast to coast. I'm actually out of New York. So, him being in Washington, me in New York. We got the North America covered. I am the channel manager here at Baicells, but I do a lot of training and presentations as well. So between the two of us, hopefully we could answer any questions you guys might have. But like Elaine said, if you do have any questions, put them into the chat window, and then we'll go ahead and answer them. So a quick blurb about the two companies. I'm with Baicells. What Baicells offers is a turnkey solution. We have everything from the evolved packet core all the way out to the end user devices and everything in between. But with us being an LTE company, we can provide the entire solution or just pieces of the solution to go along with your network, your LTE network. So if you do have, say, an Ericsson or Nokia network out there are pieces that we could change in between the two companies. So who we are, we're a global manufacturer of LTE equipment. We do a lot on the RAN side, a lot on the CPE side. So we have that down pat. We're good with that. And why do we do this? We are hoping to help close the digital divide. We're trying to offer an LTE product, cost effective, very efficient and easy to use product for everybody to be able to use. Like I said, we're global, based out of China. All of our manufacturing or building is being done in Taiwan. We have over 10 plus global tier 1 operators. We started in North America in 2016 with 47 trial operators, and since then we've grown to over 800 networks deployed.
So I'll take over about Winncom. I'll tell you a little bit about Winncom. So Winncom's a worldwide distributor of wireless and wired solutions and products. We focus on various markets and applications. And we have unmatched expertise in wireless networking. The company started in 1996 and has been serving that market since then. We offer the same we provide services to the same market that Baicells does, to the global mobile operators, to broadband service providers, to cable operators, to service integrators, service providers, and to enterprise customers. And then why are we doing it? We're bringing the latest wireless solutions and services and products to our customers. And I'm saying that we're bringing services. We're not just a box equipment distributor. We're also providing value-added services, and we do that through our Winncom professional engineering services. So with that, we provide RF design and engineering services. This includes pre-sale and post-sale support, including designs, BOM assemblies, delivery for the equipment, configuration of the equipment, and management of the equipment, and your solutions. Offering professional services to the same group of customers and enterprises. And we do it again to not just be a box distributor and send you equipment that you can't do anything with. We will stick with you and provide you professional services to go along with the products. You can go ahead, Eric. Just a little bit more on Winncom as a established value-add distributor. We represent 70 leading manufacturers. This is a wide range of equipment, not only just private LTE, but point-to-point microwave, point-to-multipoint, Wi-Fi, data networking, also all the ancillary equipments that goes along with wireless, including antennas and cabling and power and infrastructure. So we provide the whole gamut. again, focusing on solutions and applications rather than just delivering equipment. We're global. We serve 90 markets globally. We have warehouses in Ohio and Florida and Mexico and Colombia and over in Europe, again, providing professional services. So we provide the whole product design and configuration support. And like I said, we have global offices.
So understanding LTE and what private LTE is. So private LTE has essentially three primary functions, and this is across any LTE band. There's the network core, the radio access network, and the terminals themselves.
So one question for you, Eric. What frequencies does Baicells support?
So Baicells globally, we actually support every frequency, but here in North America, we predominantly deal with band 41, which is your education band, and your BRS band, where you'll find a lot of tribal nations and upper level colleges where they have frequency, and also T-Mobile and Sprint. But we also deal with the CBRS band of band 48.
Okay. And then the terminal services, or the devices, you guys, Baicells provides CPE equipment?
Correct. So we have a mixture of indoor and outdoor CPEs. That indoor being key, because that's something kind of unique with a private LTE network compared to a regular network. You could actually bring your fixed wireless device inside instead of having it sitting on your roof itself.
But your equipment's also intercompatible with other manufacturers' equipment, and you're okay with people using other manufacturers' CPE equipment and end user devices.
Oh, yes, definitely. So you'll see later on when we get into our use cases how we actually intermingle with a lot of different companies anyway. So again, with us being the entire picture or just pieces of the picture, LTE is a standards based, and you play nicely in that standards based, you're able to reach out to a lot more people.
And then you're showing the Evolve Packet Core. You guys obviously provide a packet core. Can you talk about that a little bit?
So yes, with how Baicells, partially how we make it easy, is this Evolve Packet Core that we provide. It's actually in the internet, it's up in the cloud, so it's a simple connection point there, and then you have your Evolve Packet Core to do your SIM functionalities right there, easy to use, easy to access.
With that said, you're also intercompatible with other types of Evolve Packet Cores from different software providers, correct?
Yes, yes. So a lot of interop's been done. There are many different cores out there, and I have not heard of a single core that does not operate with Baicells, whether it's the RAN or the terminals themselves are CPEs.
Yeah. So for example, Winncom also provides a Druid Evolve Packet Core that we can talk about later, and how maybe you can migrate between the two cores if you need to.
Yes. Have you done interop testing with Baicells and Druid, Mike?
Yeah, we have. Obviously, we have, and it works fine. Again, because it's based on 3GPP standards, everything's intercompatible between the radio or RAN network and the Evolve Packet Cores.
Perfect. All right, we'll move on. So what does a typical fixed wireless network looks like? This isn't private LTE. We're just going to try and get a basis of what a fixed wireless network looks like, and then show the next step going into an actual LTE, private LTE network. So a typical wireless network is kind of like what you see here. You have the internet. You're taking that internet and you want to get it out to these houses, and you want to do it wirelessly because you don't want to run fiber. So you take the internet, you bring it into a head end. That head end is normally where the network manager lies if it's not in the cloud. And then from that network manager, you're going out to each one of these towers, whether that's going to be, like Mike said earlier, a microwave backhaul, or whether it could be fiber. You're going to take your head end and distribute your data to each one of these towers. At those towers, in fixed wireless applications, they're normally called base stations. Those base stations then will distribute wireless proprietary signal out to each one of these houses and their end user devices, which are normally CPEs that are just sitting on the side of a house.
So the difference is that typically in a fixed wireless network, those end user devices they're limited, but they're actually paired up with that manufacturer's base node radio. So they kind of come as a pair. They're not intercompatible. For the most part, you can't use other people's end user devices with somebody else's point-to-point or fixed wireless base station. You need to get it from the same manufacturer. Again, that kind of makes it a proprietary solution. You need to use that manufacturer for both the base node and the residential node. The other thing about fixed wireless in a point-to-point scenario like this is it often requires a line of sight between that base node and the residential node. One additional thing is that remember that the end user devices are stationary. They're typically, mounted on the side of a house or mounted on, someplace close to a residential area, and they're not intended to move around like a laptop could go from house to house or some other device. It's meant to be stationary.
All right, thank you for that, Mike. So now let's take what we just learned from what a typical fixed wireless is, and let's move that over to how that evolves into an LTE network, or what an LTE network looks like for that. So you sit here and you look at the LTE network. It looks pretty much the same. You have the internet coming into a network manager. You have that tower. All of it almost looks the same, except for that evolved packet core. So that evolved packet core is another piece of the puzzle that makes LTE what it is. That evolved packet core is what provisions the SIMs, configures the SIMs, gives that user an identity. So a SIM card is a subscriber information module. It actually tells, whatever device that SIM goes to, exactly who it is, what plan they get, and everything. So with it being a SIM, you have different devices, Google Pixel 6 Pro, different LTE like iPad minis. All of these can connect to, an LTE network because of that EPC, because of that SIM provisioning.
And the SIM card provides security that sometimes maybe a fixed wireless network might not have. The SIM card security has been in the cellular industry for a long time, and it's very secure. The other thing too, again, like Eric mentioned, all those end user devices, you can move them around. It can be on a laptop or a cell phone or an indoor unit that's providing Wi-Fi and using private LTE for a backhaul. You can move things around. It doesn't have to be a fixed unit, and it can be anybody's unit. It doesn't have to pair with Baicells radio. It doesn't have to be. Baicells sells the CPE equipment that goes along with it, but you don't have to use Baicells equipment. You can use a wide range of LTE equipment. So it just makes it a lot more flexible. And typically you don't need line of sight for LTE.
Yes, thank you.
Sorry.
Yeah, there you go.
So these are all outdoor applications. Eric, do you have an indoor scenario?
So yeah, if we look at indoor scenarios, hey, look, there's one there. So you think about DAS, distributed antenna systems, and you also think about where that signal comes from. So similar to DAS, you could do the same thing with private LTE. Now, private LTE is your LTE network. It is not Verizon's, it's not AT&T, it's not T-Mobile, it's your network. So if you have a device that runs band 48, multiples here, you can connect it to a Baicells network. So we have indoor eNode Bs. eNode B is a fancy way of saying base station. You connect those the same route. You just connect it back to the cloud for cloud core access, or in like Winncom's case with Druid, an on-site server that will actually have that EPC as well. So what would one of these devices look like? So this is an indoor eNode B right here. And this gets you a ton more coverage than Wi-Fi. So this is actually, a very, very good use case for a lot of different scenarios. Mike, you have a few in mind that would be great to be used for indoor?
For other devices?
For other devices, yes.
Yeah, so like we were talking about, because it's built on 3GPP standards, you can use any device. So Cradlepoint makes a device. Winncom also distributes or represents a company called BEC, and BEC makes lots of indoor devices that supports Wi-Fi on the client side, acts as a bridge and a router. Yeah, there's at the start of CBRS, there were just a few limited devices. CBRS has been out for over 3 years now, and devices are becoming much more popular. You can, like Eric said, you can get it on a laptop or a iPad or your cell phone. There's tons of devices now.
Yeah, so and to see a list of those devices, OnGo Alliance certifies the end user devices. You could go there and see exactly what devices are certified for band 48. And currently, I believe it's right around 585 current devices certified to be used on band 48 LTE networks.
So the unique thing about a private LTE network, again, is the evolved packet core that's required in LTE. And Eric's got the picture here where there's a cloud EPC, and that can obviously be Baicells Cloud Core that they offer in the cloud. But it can also be an on-prem EPC. You can load Baicells software on a local server and have it on your premise. They're also, again, 3GPP standards. They're intercompatible with other people's evolved packet cores. Like, again, Winncom distributes Druid software for an EPC. So the indoor one or the on-prem one could be a Druid EPC that Baicells would work perfectly with. The other unique thing is that that you can also kind of start with a cloud, start with Baicells Cloud Core, get used to it, get the benefits out of it. But then if you find and it's easy, right? They make it easy. But if you find that you want, maybe more control or more usage of it, and that you want to own your own, you can migrate the Baicells radios from the Baicells Cloud Core over to a Druid core that you would have on your own prem that you would then own.
So
one more unique thing is that typically the data plane from the devices gets dropped off through the packet core, through the packet gateway on the evolved packet core. And Baicells has a very unique feature for their radios where they can have a local gateway and drop the data plane off locally, which then makes it really a private LTE network. So the devices that are on your prem can drop off the data plane locally and actually get attached to your enterprise data network to access your local servers. They don't have that data plane doesn't have to go out to the cloud and just to the internet.
perfect. And so to attest how easy it was, I actually had somebody contact me earlier and say, hey, I'm about to add a whole bunch of SIM cards to my network. Can you help me later today? I was like, sure. After my webinar, I have a meeting, and then after that meeting, I'll contact you. So he actually just texted me about 10 minutes ago while we're on this call and said, dude, this was the easiest thing I have done so far. It's all done. I don't need your help right now. So it really, really is simple to get into LTE with Baicells. And then as you learn and evolve, you can simply move forward because of that 3GPP standards and learning other cores, for example, or other RANs or other end user devices. So let's talk about how Baicells does make it easy. We're sitting here saying it, but how do we do it? 2 slides ago, you actually saw a private LTE network, and you have 2 servers. Even those servers are small, they're getting to be a little bit more inexpensive, and they're very powerful. You could seriously, have a server this small. But if you don't want to pay for the software, pay for the service, learn on the fly about how to use a network manager and a core off the top of your head, you can simply utilize the Baicells Cloud Core. Inside the Cloud Core, we have 2 functions, the OMC, which is the network manager, and then BOSS, which is the actual SIM provisioning portion of Cloud Core. So I learned LTE 5 years ago, starting with Baicells. I wasn't working for Baicells at the time, but that's where my knowledge of LTE started, was learning on the cloud core. And then it expanded there to other cores, just because, once you start with it, you want to get to know it. You want to learn more. You want to do more. You want to learn more. You want to do more. It becomes kind of a hobby right along with a job. All right, Mike, anything you want to add to this one?
Yeah, obviously I've worked with your equipment and your cloud core, and it really is easy. Baicells kind of delivers that whole bundled package of you can use Baicells CPE, you can use their radios, you can use their cloud core, you use their SIM cards. They make it a bundled package that makes it super easy to turn up and actually use. And then if you want, if that's not working for you, if you want different features or if you want a different architecture, you can, again, like we've been talking about, you can use other people's CPE. You can use a different evolved packet core. So you can kind of change and mix things, but at least there's an easy way to start with a bundled package from Bicell.
So, and we might be getting ahead of ourselves here, Mike. Have you done a full installation for a customer? I mean, not the physical portion, but going into the cloud core, doing the SIM provisioning, and actually configuring a radio?
Yeah, so I have multiple times, and I've done it both on CBRS and on Band 41, because you guys obviously offer those two spectrum groups. Again, super easy to do.
Okay, perfect. That's what I like to hear. All right.
And then I just wanted to kind of touch on how Winncom can make private LTE easy for you guys to implement. So not only do we provide just the radio equipment from Baicells, we provide it from other manufacturers. We provide the private LTE, the private LTE Evolve packet core. That's either the Baicells Cloud core, or if you want your own on-prem Druid packet core, we can provide that for you. We provide all the end user equipment that's associated with that. Could be the Baicells Atoms, but it could be also, Cradle Points or VEC equipment. And then in addition to all that, just be aware that Winncom can help with all the other ancillary equipment that would go along with your private LTE installation. So if it's an outdoor application, you can see this drawing here. We can provide everything that's on this drawing and everything that you would need. So some of the Baicells radios, some of them have internal antennas on them, even the outdoor ones, but some of them don't, and they need antennas. So Winncom can provide a wide assortment of different antennas for Baicells radios, and obviously the jumpers that go, the special jumpers that have different connectors, whether it's on the radio or on the Baicell. So there's specific jumpers that you need to get. Winncom obviously provides that. The GPS system, Baicells comes with a GPS antenna. If you need other GPS antenna solutions, Winncom can provide that. Obviously, the fiber optics and the Ethernet and the power cabling that would need to go down from a pole or from a tower, we can provide that pole or tower infrastructure. And then obviously you need power to power up the radios. Winncom can provide all sorts. We have professional engineers that are expertise at power systems, and we represent different power solutions through various vendors. And then obviously you need to attach that to some type of data network to get it back through your enterprise network or back out to the internet, and we provide the data networking gear to go along with that. So Winncom can provide this whole solution end to end with Baicells equipment, and then all the other extra ancillary equipment that you might need for it.
So I see down there it says warehouse staging. Does that mean you guys actually do everything at your warehouse and then pack it up as like one crate and ship it to an address?
So we're super flexible. If you just want equipment shipped to you, we can send equipment to you. If you want your equipment pre-staged and pre-configured and set up and tested, Winncom can certainly do that for you before we ship it out to you.
All right, perfect. I'm gonna move on to the next one. All right, now talk about you as an engineer, Winncom engineering itself.
Yeah, so I just talked about like all the equipment that we provide, but remember I said that Winncom also provides value-added services, and how do we do that? We do it through our professional engineering services. So again, unique private LTE experience or expertise, so we can provide consulting with that, but that's everything wireless too. So it's if you need help with microwave systems or point to multi-point systems or data networking or Wi-Fi systems, we have professional engineers that can support all those areas of expertise. We can do the private LTE design for you. We can do predictive coverage. We use tools like ATOL and IBWave and Network Planner. We'll do the design of your private LTE network and work with you to do that. Create a BOM for you so you know what equipment that you need. And again, it's not just the LTE equipment. It's for the BOM. It's all the equipment that's necessary to get your private LTE network to work. If you need lab testing, either before to make sure something's going to work, or maybe post delivery or post configuration, and then you need something tested, maybe for troubleshooting, Winncom has an extensive lab for doing all that testing work in and doing the setups. And like I said before, we can do all the configurations or help with configurations or do it for you, which includes the radio equipment, so we can set up the element management system that typically comes along with the radio systems or the radios. We can help with SAS registration. We can help with spectrum. Like I said, we've done CBRS deployments. We've done band 41 deployments. With band 41, we've helped customers determine that they have interference from other band 41 carriers that are affecting the performance of their private LTE network. So we can help with all those things. We can help with the Evolve Packet Core. We can install the Druid software on a server for you, get it all pre-configured, and then ship it out to you. And then obviously we can help with the end user equipment or CPE as far as configuration or helping you get used to it or learn how to use it or how it works. So that whole gamut. And then we can also help with deployment. We don't actually have a professional service where we would go out and necessarily install everything for you. But if you do need help with installation services, we can have somebody on site that could help with the radio installation as far as consulting, or with the power system. We have excellent power engineers that can help out with all your power engineering needs and installations. And then on top of that, we have ongoing support. So if you have a private LTE network up and you need help with it when troubles arise, then we can provide consulting services to help you out with it to keep it up and running.
Man, that sounds impressive, Mike. It really does. Yeah, your engineering services I heard is top notch, especially being able to do the predictive coverages with ATOL and IBWave. That's a huge part of a network for when you're learning and trying to figure out exactly what should and shouldn't be covered. So again, that is, I think that's by far a great value add is that, that engineering team that you have there. So let's look at a couple of case studies. We'll probably move through these a little bit quickly and just, hit on some key features of them. So first we have a city of Vegas here. And you'll see there that we have 4 of our eNode Bs sitting on top of a building. That is a community center 2 blocks away from Stratosphere. And when, the city of Vegas came to us and said, hey, the pandemic's hitting, we need to get a network up and running as quickly as possible. What can we do? So what we did is we said, all right, we can hand you, we can get you these eNode Bs. We can get you some indoor CPEs, what we were talking about earlier, how you can have indoor unit versus outdoor units. So what they did is they set up their eNode Bs at the top of this building. And then from there, they handed out different indoor CPEs to customers and said, hey, put this in your house facing the window and you'll be able to connect to our network. So within 45 days, they were able to get, most of their students up and running quickly. This was no truck rolls, just easy. Here you go, off you go.
So the one thing I wanted to mention is that in this picture you can see that there's the 4 Baicells radios. You can actually see the GPS antennas kind of hanging off the radios, and then everything else are the items that Winncom can supply and help you with, right? So up on that pole that's up in the air, there's antennas. There's the jumpers coming down from the antennas. You can probably see some, maybe a little bit of power distribution or Ethernet distribution there. You can see some interduct probably going to a power supply. Again, we can provide all that equipment, the antennas, the cabling, the jumpers, the power supplies, the Ethernet cabling, the DC wire, everything that's involved with it, and then help you to design it and deploy it.
Perfect. Yeah, and the amazing thing about this network here is they deployed it with the cloud core to start. And then after they got this network up and running, they decided to do more with this network. So the first thing they did to do more was actually move from the cloud core to a different core. So they were easily able to evolve their network by moving away from the cloud core to do more with it. So after they did that, they had some parks, it's Vegas, that probably had, some sketchy characters there. So they wanted to do video of the area to hopefully, get rid of some crime. So they were able to take that video feed and bring it back through their LTE network because they switched out cores and they were able to do more with this other core. All right. So on the solution architecture side, the terminals were our indoor category 6. The radio access network was our 436 Qs. And on the network core, they started with cloud core, but evolved it to an actual on-premise core. All right. So the next case study we'll look at is going to be a medical facility in Japan. They were having issues with their Wi-Fi network, and sometimes their doctors and nurses were having issues getting on and getting an actual connection and a very reliable connection. They also had issues with some areas, a little bit farther away from the AP that they weren't getting connections to. What they decided to do was take their Wi-Fi, instead of removing it, they figured, hey, let's build on a different network, another network to help, with those doctors and nurses and that little robot that goes around distributing pills. So they built an indoor private LTE network utilizing basically this device right here, the Neutrino. And it's an indoor eNode B. So they were able to do that. Oh, go ahead.
I don't think you advanced your slide there.
What slide am I on?
Las Vegas.
That's not good. Is it not moving?
I see Las Vegas.
Elaine, are we having technical difficulties?
You're showing slide 20 right now.
Okay, good. Okay, it's just on your end right now, Mike. So that's not good. Thank you, Elaine. I'll keep going. Hopefully, Mike, it catches up for you. But that's weird that you can hear me but not see the actual slide. What slide are you showing? Still Vegas?
No, now I see the medical center.
Okay, cool. So after they switched over to the private LTE network, their doctors and nurses have their own private network that they were easily able to keep up with the times, to get onto their network for the doctors to be able to stream any kind of surgery they had. I think the most important key about this is hearing the story about Wi-Fi not being able to go far enough. And that's where someone like a Winncom engineering could help out. Go ahead, Mike.
Yeah, so because that's an indoor application, obviously Winncom can help you out with the design of that, use an IB wave to design out, what your coverage and capacity needs need to be, and where you need to have cabling and all the other ancillary stuff that's associated with that design. Winncom can help you with.
Oh, perfect. So, Mike, you want to go over this slide real quick? What that looked like from a solution architecture overview?
Okay, so I'm seeing the medical center picture.
Oh no! All right, I'll go then. So how this solution architecture looked like is the radio access network honestly was the only piece that Baicells touched. So we only provided that RAN, the eNode Bs that were in the building. They had their own tablets, their own phones that connected back to these bands. They had their own smart devices. All of that was different than Baicells. And even the core wasn't Baicells. So again, with it being LTE, we were just the middleman there, that transport getting everything through. You don't always have to have a single manufacturer, single vendor in LTE. You can pick and choose where you want to go and how you want to get there using LTE. All right, advancing my slide. We're on Utah Education Telenetwork. Are you there? All right, good, good. All right, cool. So our last case study that we're going to look at is UETN, Utah Education Telenetwork. Basically, the state of Utah said, hey, I want all of my school systems to be able to talk on the same network, same private network. So what they did is, for the RAN perspective, they utilized Baicells. They put out an LTE network that's 17 counties right now, and there's going to be more in the future that connect back to this private LTE network. And how they did that specifically was on the core side. That core was able to distinguish which county is which, but at the end of the day, have every one of those counties report back to the same network. Mike, you with us?
Yeah, I
right.
can see the design now.
Okay, okay. So you want to talk about the terminals on this one?
Yeah, so I believe they use cradle points, right?
Correct.
Yep. So here's an example of a cradle point CPE device. Again, it can act as a router, kind of like as a bridge to connect to integrate into your enterprise Ethernet network. It also has the built-in Wi-Fi on the client side. So if there are still applications for Wi-Fi, you can use the private LTE as a backhaul and then deliver Wi-Fi to your end users. So again, this whole concept, like private LTE isn't necessarily a replacement for Wi-Fi. It's to use private LTE maybe as a backhaul for Wi-Fi, or like Eric talked about, where you have critical applications where your Wi-Fi network might not be good enough, and you want to put that separate application on a dedicated private LTE network.
All right, perfect. We did have a question come in. The question was, if I have a CPE UE not listed on OnGo list, would you test it for us? So the testing process is to go through the FCC certification process, which is part of that OnGo Alliance, the CBRS alliance out there. We can test it across, band 42, 43, or 48 on our RAN. But outside of that, we can't, certify it to say, hey, it's going to work with other vendors across the LTE platform in CBRS.
Yeah, we could test to see if it works, but we can't certify it.
Yep, there you go. All right. So I think most people are here just because of 5G. You throw out a word, everyone wants to get in on it. So let's talk about 5G for a minute. The first thing we're going to discuss is, some quick terms. You ask a lot of people, and a lot of the questions that people don't know about 5G actually could come from here. So the first thing you see with every eNode B, it's going to say whether it's NSA or SA. And what that basically means is standalone and non-standalone. So NSA is non-standalone, giving you the ability to connect to a 4G or a 5G core, whereas SA is standalone, and you could only connect to a 5G core. All right, so on the modulation side, well, 4G currently maxes out at 64 QAM on the uplink and 256 on the down. So in 5G, you could already see that uplink is starting to increase. Why does that matter? You're looking at all of these grants, 100 by 20, 100 by 100, and this is where that uplink comes into play. With your configurations, you could play with your downlinks versus your uplinks, and that's called periodicity in 5G, whereas with 4G, it was called subframe assignments. With periodicity, 100 megahertz. With one periodicity, you get 850 down with 230 up. With another periodicity, you get 655 down and 330 up. And your expected latency is going to be about 10 to 15 milliseconds lower than what you get currently on 4G. All that look good to you, Mike? Anything you want to add?
Well, so Eric, you can still, even though it's 5G, it can still be a private LTE network, right?
Correct. It will still be your network. You'll still run it on, we're going to talk about bands here in a second, but there will still be bands for the general public, general users, and also that, again, band 41.
Okay.
All right, so let's talk about the band. So band 48 is CBRS, and it is referred to in 4G technology as B41, 48. When you move over to 5G, it actually has multiple bands inside of it. You have N48, which is pretty much B48. N48 will do up to 40 megahertz in 5G. So one channel being 40 megahertz, where in 4G, the current maximum channel size is 20 megahertz. You can aggregate channels to get more, but the max channel size in 4G right now is 20 megahertz, whereas 5G, it's going to be 40 for N48. When you move on to other LTE bands, N77, N78, you're going to see higher bands available, higher channel available. So now you, instead of having 20 for 4G, now you have 100 in 5G. So what does that do? So N48, if you aggregate two bands of 20 currently in 4G, you can get about 300 down using just 2x2 technology, that is. You could get about 290 down max using 256 QAM and right around 28 up. So the improvement of going from carrier aggregating 220s together for 40 into 140 megahertz with N48 40 megahertz 2x2 about 340 down and 132 up. And a test scenario we actually did at a conference, we were able to get 270 down across our 5G network and 97 up. The up wasn't, 132 in this test network because there were a lot of 5G devices in there. It was a 5G test bed. There was quite a bit of interference. So when you go from N48 to N78 with that 100 megahertz, that's where we get back to that 850 down. When you get into 4x4, you can start reaching those 1 gig territories on the downlink pretty quickly, pretty easily. Oh, wrong way. All right, so band 41, same thing. It was B41. It is now becoming N41. You still have about that same 200 megahertz of usage for tribes or EDU or T-Mobile, and then you do have that 100 megs where you can max out at 850 down with a 2x2 system or 1.7 gigs down on a 4x4 system. All right. Anything you want to add to that one, Mike? Nothing?
I'm excited to see your equipment.
All right. Let's get into the actual 2023 product lineup by Baicells. So currently, we actually have one product already FCC certified. This is certified for N48, so max of 40 megahertz. This is the unit that we were doing testing on, getting that 270 down by 97 up. This is that product. The other bands will be coming out over the next couple months, in which you can see that 100 megahertz take place.
Can people buy that today?
Yes, you can actually buy this today. We are shipping this device. But the one thing is you do need your own 5G core with this one. We're still in development with the cloud core.
So that's where Druid would come along.
Correct. All right, so our first venture into indoor 5G is going to be the Stellar 227. This is an indoor, you heard us say eNode B. With 5G, it's Gnode B. This is going to be 2x2 MIMO as well. N78, not N48, N78 and N41. So this is going to be able to get you that 100 megahertz inside buildings. So, hospitals, casinos for tribal nations. This is a great device for all of those.
Is that available today?
No, this one sadly is not. I believe this will be ready in the next probably 4 to 6 months. All right. So later in the year, probably fourth quarter of this year, if not first quarter of next year, we're going to have 2 more standalone products come out. One's the Aurora 249. Again, this one's going to be an N78 and N41, 100 megahertz, so that 850 down, and the Aurora 452. 78 again, and N41. This is going to be our first 4x4 5G product, and that's going to get you, you know, all conditions are met, 1.5 to 1.7 gigs down. All right, and the last ones, certainly not the least, of course, the CPEs. You got to be able to talk to those G-Node Bs. So we have two variants coming out. We have the indoor variant, and then we have the outdoor variant. They both are dual mode. They'll work on 4G, so you can put it up with your current 4G, and when you swap over to 5G, you won't have to change out your CPE. So these can work in one mode or the other. It could work in a 4G system, a 5G system. The indoor unit has Wi-Fi 6E built into it. In our outdoor unit, the Wi-Fi is for alignment purposes only.
Are those available?
I love it. I love it. So these, I think, will be ready as well in the next 6 months, right alongside with our indoor unit. All right. So that's everything we have today. If you need to contact us, Winncom at sales@winncom.com. If you want to get a hold of Baicells, you could go on our webpage, baicells.com. You can get a hold of us there, or you could actually email me direct, eric.randall@na.baicells.com.
And you can find out more about Winncom at winncom.com.
Perfect. Any other questions before we close this out? All right, perfect. We'll go ahead and end this today, guys. Thank you for joining us. Mike, want to say goodbye?
Thanks a lot.
All right, take it easy, everybody.
Thank you.
Thank you.
Bye.